On to a new topic, inheritance. This is a new feature of the Python object system, and it's a feature that exists in almost every object system in every programming language. So inheritance is a method for relating multiple classes together. Because not every class exists in isolation. Sometimes one is just similar to another one, and we want to express that relationship. So the most common use case you should think about when using inheritance is when you have two similar classes that differ in their degree of specialization. So the specialized class might have all the same attributes as the general class, along with some special case behavior. The way you express this syntactically in Python is that in addition to having a class statement with a name and a suite, you can also put in parentheses a base class. And the base class is what this class inherits from. So conceptually, what happens is that the subclass, the one that we create with this class statement, shares all the attributes with its base class up here. The subclass might override certain inherited attributes in order to change its behavior slightly, but anything that's not changed stays the same. So using inheritance, when we write down a subclass of an existing class, all we do is we specify what's different about this subclass from the base class. Everything else stays the same. Let's do an example. So, let's say we have a checking account. It's like an account, but special in the following way. When you create a checking account, you still give it a holder, but its interest rate is lower than the interest rate that you would get on a normal account. So you get less money every month. When you deposit, it's the same thing as before. You add money to your checking account. When you withdraw money from your checking account, you incur a withdrawal fee. I mean, the bank has to make some money somehow, right? So when you withdraw $5 from your bank account and there's 20 in there, what's really left over is a balance of 14. Okay, so most of this behavior is shared with the base class account. So all that's different is that we have a lower interest rate, and when we withdraw money, we have to pay an extra $1. Okay, here's how we write the code for this checking account. We say there's a class called checking account. Its base class is account. Another way of saying the same thing. We'll create a class called checking account that inherits from account. So this is a bank account that charges for withdrawals. We set that withdrawal fee to be $1. We set the interest rate to be 0.01 instead of the usual 0.02. And then we also have to change the withdrawal method, because writing down withdrawal fee might seem like it's helping us get in the right direction, and it is. But we haven't ever said how to use the withdrawal fee. So we have to write down a method that does that. And we'll write down the withdrawal method. So the withdrawal method takes some amount, and what it does is it withdraws from the current account the amount that was specified plus whatever the withdrawal fee is for this current account. Now, why do I keep saying current account when it says self right there? Well, remember that self is the name we use to refer to the object on which this method gets invoked. So when we actually call withdraw right here, self will be bound to this checking account, which is currently called ch and was originally created with this call to checking account. Okay, so we'll withdraw $5. Amount will be 5. We'll add in the withdrawal fee of 1, which is shared among all checking accounts because this is a class attribute. And then, how do we actually do the withdrawing? Well, that's the interesting part. We refer to the method on the base class called account.withdraw. Now, since we're looking this up on a class as opposed to on an instance, we're not going to get a bound method back. We have to supply the self ourselves. Okay, since we put account here as the base class, we don't need to say anything about depositing. That just stays the same as it was before. We don't need to say anything about init. That just stays the same as it was before. So checking accounts start out with $0. Okay, so let's talk about looking up attribute names on classes. The base class attributes aren't copied into the subclass. Instead, it's part of the process of looking up an attribute by name that gives you the behavior that an attribute of a subclass that isn't changed is just the same as whatever the base class was. So to look up a name in a class, here's what you do. If it names an attribute that's in that class, then return the attribute value. Remember, attributes are name-value pairs. If not, look up that name in the base class, if there is one. Now, the base class is just a class, so we recursively are doing the same thing. We'll look there, see if that attribute's in the class. If so, we'll return its attribute value. Otherwise, we'll look up in the base class of the base class. Okay, so let's talk about exactly what's happening when I create a checking account. I pass in Tom as the holder. Since the checking account class we just defined doesn't have an init method of its own, we look up the name init. We don't find it in checking account, but we do find it in account. And so that's the one that gets called. And that sets the balance to 0 and the holder to Tom. When we look up the interest rate, well, there is a special interest rate for the checking account, so that's where we find it, and it's 0.01. When we deposit, all that depositing happens from the accounts method. So here's what we do. We try to evaluate this operator expression, which is a dot expression, which means we look up deposit on this checking account. We check in the instance, no deposit attribute there. We check in the checking account class, no attribute deposit there. So then we check in the account class, and it has a method called deposit. So we get back a bound method here, and we call it on 20, depositing $20 in the account. And finally, when we withdraw, well, we find that in the checking account, and that gives us 14. Okay, let's just write the whole thing down so that we understand what's going on. So on the right, you see the account class from last time. So in addition to the class that we have, we're going to create a class checking account, which inherits from account. It has a different interest rate. It has a fee associated with all withdrawals of $1. And the way that fee gets used is that we write a withdraw method that withdraws not just the amount, but $1 extra. Okay, now it's reasonable that we could just copy this over, right? Say, okay, the first thing we're going to do is we'll add 1 to amount, and then we'll go through and we'll check and see if the amount is too big. If it isn't, we'll say insufficient funds. If we're okay, then we'll change the balance and we'll return that balance. This would be correct for a while, but the problem is if we made changes up here, they wouldn't be reflected down here. So that's why instead, in the example that I showed you, I said, let's actually just use the implementation we have already, account.withdraw. That's this function right here. And what does count.withdraw take? Well, it takes self and account object as a first parameter. And the second parameter is the amount that we want to withdraw, which is whatever amount was passed in here plus the withdraw fee. Let's quickly verify that this works. So if I have one account that's an old kind of account for John, and then another account which is a checking account for my good friend Jack. So A is an account, B is a checking account. They both have a balance of 0. Let's add a balance to each by depositing into 100 in A and depositing 100 in B. Now both of those did the same thing because they're both using the same deposit function over here. But if I withdraw $10 from A, I have 90 left, or if I withdraw 10 from B, then I have only 89 left because I use this withdraw fee.